Okay, so this will just be a quick video going over, this is question 7 on your assignment for today. So this is number 7, okay? And so we give you 3 different problems that you're going to be balancing to satisfy law of conservation of mass. You can use the box method or the line down the middle. I will be using the box method for each of these examples. And you can show your work on paper, Google Slides, or a Jamboard. So remember, you have this option to always click these 3 dots, and you can make a copy to submit your stuff that way, okay? So this is a really nice resource. Okay, so moving on to the first part, we have silver nitrate, we have copper, we have copper nitrate, copper 2 nitrate, I should say, and silver, okay? So we're going to draw our little squiggly down the middle, okay? A little hint for this that I want to point out right from the start is kind of something that was used yesterday with that hydroxide. When we have these polyatomics, okay, and you notice that we have the little parentheses there, we're going to actually treat this like it's its own entity. Like you are going to leave the nitrates together. So we are literally going to put those parentheses into our box. So what you see me draw right here is I'm going to have Ag, and I'm going to have my NOOO, and I'm going to put parentheses around those guys and then put it into the box. And what that forces me to do is to keep these together, okay? You could even do, if you really wanted to, sorry, not to delete everything if you just wrote it down, but we could also just leave it NO3 because we know that it's its own thing and we don't actually have to draw out each thing, okay? So we can do it this way as well. Then we're going to draw our copper, like usual. We can draw our copper, and then we can do our nitrate, but we're going to go NO3, NO3, right? Because there's 2 of them. That's indicated right here. Put them into a box, and then an Ag will go into its own box. Now we can start balancing. And what you see that this will help with is that now we don't have to worry about balancing oxygens and nitrogens, right? We're going to balance nitrates, the polyatomic. So what we see first is that we have 1 silver, 1 silver. We're good to go. We have 1 nitrate. We have 2 nitrates. So what that tells me I have to do is we're going to balance the nitrates first by drawing another box of silver nitrate. Now I have my 2 nitrates here, 2 nitrates here. I have 2 silvers, so I'm going to go ahead and add in another silver to the product side. I have 1 copper, 1 copper. This is now completely balanced, so you're going to follow up with that last step, which is counting up your boxes. So we're going to have 1, 2 for the silver nitrate. We're going to throw a 2 in this first box. We have 1 copper. We have 1 copper again, copper nitrate, sorry. And then we have our 2 silvers down here at the bottom, or at the product side, sorry. Okay, so 2, 1, 1, 2 was going to be that final answer. For this next one, I will help you with the boxes, but I'm not going to give you that final answer. But be sure you are showing all your work. Okay, so for the next part, part B, we now have some sodium phosphate. Okay, just so you know where all these little numbers are coming from. Phosphate is a polyatomic, so I'm going to put parentheses around it. Phosphate is also on the product side, so that PO4, go ahead and put parentheses around that one. We also see hydroxide on both sides of our arrow. So since we're seeing that polyatomic on both sides, we're going to leave them in parentheses again, just like we did on that previous problem. Okay, so we're going to start our box method off by saying we have 3 sodiums and we have only 1 phosphate. So we're going to leave it together like that. We're going to put a box around it. Okay. I've seen students in the past even put a triangle for that, and they'll just put a triangle in the box so that they know it's just one thing, okay? So you can do whatever works for you. That's kind of a cool method to use as well. All right, so now we have potassium hydroxide. So I have a K, and then I have that OH that I'm going to leave in parentheses. We're going to put that into a box. Okay, over across the arrow, the yield sign, I have 1 sodium, with one of those OHs. And finally, I have our potassium phosphate, which will be 3 Ks with a phosphate. So 3 potassiums and a phosphate. All right, so looking at this, we're going to start balancing. So we first notice that we have 3 sodiums over here, but we only have 1 over here. So I'm going to go ahead and fix that right from the start, and I'm going to go ahead and make my 3 sodiums appear by adding in additional molecules of sodium hydroxide. So now I have my 3 sodiums, we're good there. I have 1 phosphate on this side, I have 1 phosphate on this side. Then I have 1 potassium on my reactant side, but I have 3 potassiums on my product side. So I'm going to go ahead and draw in 2 more of my molecules of potassium hydroxide so that I have 3 potassiums on my reactant side and 3 potassiums on my product side. I'm going to double check my last item, which is my hydroxide. I have 1, 2, 3, 1, 2, 3. My pictures match up on both sides. So follow up with that last step and count your boxes in order to fill in your different coefficients that are missing. So again, as a recap, put your polyatomics into parentheses or replace them with a shape, like a triangle, or you could put a square or something like that. All right, letter C, the last one. First, on a side note, if you have opened this assessment or this lab early, then you see that you have an additional MgCO3. Please know that I will hand grade this question. So if you do have 2 of these on your letter C, then it means that we didn't catch that typo beforehand. So we have fixed it. If you're now opening it and if it looks identical to what's on my screen right now, then you don't have to worry about anything that I just said. But if you have 2 of those, just treat it like you only have 1, and I will hand grade those. Okay? All right. So for our last one, I'll kind of just give you hints on how to draw those first boxes, and then I'll let you finish the process. So we're going to put my squiggly down the middle. What I'm noticing is I have magnesium on both sides, I have fluorine on both sides, I have lithium on both sides, and then I have this CO3 thing. So I'm going to put my CO3 into parentheses, and that'll be the polyatomic that's going to end up in our box. So when we go to draw our boxes, I'll help you with the first row only, and then you'll balance the rest. Mg, and then 2 Fs. We're going to throw that into a box. Li2CO3. So I'm going to have 2 lithiums and 1 of those carbonates, the polyatomic. Across the yield sign, I'm going to have an Mg, or magnesium, and only 1 carbonate. And finally, I'm going to end with my LiF, lithium fluoride, and put that into a box. So hopefully you're kind of already seeing that this should be a pretty easy fix. I have 2 fluorines and 2 lithiums on this side, and I only have 1 of each on this side. So continue showing your work. Make sure you take a snapshot of your work to submit on the next question, and that should get you through this question.